So hello and welcome to yet another video, and today we do have a B450 mainboard here, but it is not an MSI board, it is not a Pro VHD Max, but it's a Gigabyte board. So let me get this unpacked, because we do have a B450 B450M DS3H from Gigabyte, including also the arrow bracket. And let me get this cleaned up and we will look at the mainboard. So before we're getting into the repair, I was approached by this company selling microscopes on Amazon, and they asked me if I would want to do a review for them. And this is what you can see right now. This is the big package that we have. And I was sponsored by them, so this was given to me for free. But I didn't get any money for the review, but the product itself. And I was told I could do the review however I want. They just said it needs to be 6 to 8 minutes. So everything that I said is my opinion on this microscope. And I wasn't paid to say anything about it. But we will be using this microscope for today's repair. And now we have this huge package on our desk. It's an ELIKLIV, I think that's how we say it, 3-lens IPS digital microscope. The model is the EDM601 Flex, EDM602 Flex. Let's get this unboxed together. Let's open this up. This is just, I'm not used to have something this big on my table. It's quite hard to capture this properly. To show you, for example, this is a ATX mainboard that I usually work on, in a bigger one, and you see how much larger this box is. So let's see. And holy smokes, is this a big screen. It really didn't look that big on the product page. Oh wow. And yet again, the mainboard for scale. This is insane. So this thing is 25 centimeters almost by, what is it, 28? No, 18. So the actual screen is around 22.5 times 13. Quite huge. Okay, let's get this to the side first. I'm very interested in this mounting mechanism, how I will be able to mount this. Let's see for the outputs, what do we have here? This looks like mini HDMI right there. This looks like a USB-C and an SD card slot. There might be a microphone in there as well. There. Looks very good. Let's see, is there an SD card? There's even an SD card included. Very nice. This is a 64 gig. Good to know. So next we have one power adapter. This outputs 5 volts, 2 amps, USB-A. We have a remote, little screwdriver for installation. Probably some pinching screws. Let's see what this is. This is for something, for some mounting, probably. This looks like there's an LED in there. Let's see how this one will work later. No idea what this is. Okay, the manual. I will quote that if I need to. This is the actual piece that holds the microscope in place. Here we have one of the big selling points of this. These are probably the lenses, if I'm not mistaken. Oh, these are examples. Interesting. Pine stem. Okay, we might have a look at these later. Oh, this one even comes with a microscope LED light. I didn't even know that. It's very nice. And next up, let's look at the mounting. So, this one is hefty. Like, this is ginormous for the mounting. This uses a clamping mechanism. I won't be using the clamping mechanism. I will be drilling a hole and mounting it via that. But this clamp is huge. This will definitely hold on well. And we have a USB-A to USB-C adapter to put on the back of the unit to power it. Some mounting hardware. We got a USB-A to USB-C right angle adapter, so this will also be very handy. We got probably control for the lights, again with USB-C, with USB-A, and probably a plug for the light to probably turn it off, make it brighter and dimmer. We will see for that. One HDMI mini to HDMI cable. We got some of the clamps that will hold this thing together, as you can see. We'll be very interested in that, just like the mounting pole that we have right here, and some more for the base. And this thing even comes with yet another soldering mat. I won't be using this. If you're familiar with my older videos, you've seen exactly one like this. But we don't use that anymore, but still, it's very nice. If you're getting started, this is insanely cool. So I'm currently still in the setup of getting this fixed to my table. And I gotta say, the build quality is really nice. This has hex screws, and the screw holes are all countersunk also. And look at this nut even that they use. They use these nylon nuts, which are self-locking. Like, really good stuff here. Like, I'm impressed by this build quality so far. And this thing is real heavy. Like, this won't go anywhere as soon as you have fixed that to your table. I want to show you the highest magnification now on this one with the lens that is for very short distances. As you can see, this is some cable sleeving, some very, very small cable sleeving. And this is some packaging material. And you can actually see the color pretty well. It's really hard to focus. I won't be using this lens because it's not feasible for doing electronics repair. But this is really interesting that this thing can even get this far down to a magnification. And this is now the middle magnification, as you can see. This still gets quite deep. Like, you can magnify pretty good, and the distance between the actual object and the lens is way bigger now. I will show you that in the spec sheet later. And this is now the one with the furthest away magnification. And as you can see, still looking very good, but this one is obviously not for going insane into detail very deeply, but still looks very good. This is, for example, the tip of my screwdriver for comparison, so you can also know what kind of lenses we've been using before and how deep we went into the magnification. So I now want to show you the setup as far as I've gotten it. You now can see the huge screen as by my hand size. We have the front I/O, for turning on, turning off and stuff like that. You see here a board right under it. You see the LED ring light that came with it, going brighter and dimmer, and also having an on-off switch right there. Mounts with just some pressure screws right there. You can see right there. And all of this goes onto this beautiful arm right here that swivels in multiple directions. Like, the thing what you can do is you can go up and down with the microscope itself with this mechanism right here. Then you can also swivel this joint to the top and to the bottom, and also to the left and to the right. Then you have another joint right there that you can open and close. And then it goes to this pole, which is, in my case, just mounted to the table. Here you can see these things are for cable management. So you can pull these off and put cables into the bottom here, as you can see, to cable manage it. And the same one goes here on this side. And this is basically the whole contraption. And the backside, as I showed before, with USB-C connected, the SD card. And what I always do, I do not use this huge screen, even though this screen is really good. I gotta say, the quality of this microscope is pretty good through this screen. But what I'm used to is to do the following. I'll always connect my TV to it. So I have HDMI output, so I'm easier able to capture the output. And this also looks very good because you need to think you're looking through this camera, looking onto a screen, onto another TV. So yeah, this is the setup that I've got now, and I gotta say I pretty like it. But let's get into doing a repair with this here microscope. And to quickly show you again, this is the usual way how you would mount this, where this is the big round stock that you would have, and this just mounts via pressure to your table. Not in my case, because I screwed directly into the table, but this is the easy setup. So let's get into this repair then. This board came to me for no boot. We will do the obvious checks for short circuits first. So let's get our multimeter onto here. So let's now do our usual checks. We get a ground right here. Let's go into here. This should be 12 volts, 2.4 kilo ohms. Then we go into 5 volts. Also kilo ohms and rising. We go into 3.3 volts, kilo ohms and rising. We go into 5 VSB, kilo ohms and rising. We go onto PS on and open line. So let's go into the 12 volt CPU. And do we really have a short circuit on 12 volts? Seems like it. Yes, we have a short circuit on 12 volts. Very, very interesting. Okay, so we instantly know where to look at. There's a single cooler on here. Let me get that VRM cooler off, and let's inspect the board under the microscope and see if we can already determine any problems there, just by visual inspection. So let's now inspect the VRM area right here. And so far so good. So far all of this looks very, very clean. I can see what we are looking for is for squeezed solder balls somewhere. And there I can see one. Here. It shines very nice in this microscope. If you can see it right there. On the left MOSFET, on the 4C10N, that's a solder ball. And also right there, also, and at the top there. So I think it will be this MOSFET right here. Let's mark it like that. But let's continue in the area. But I think just by visual inspection, we've already found our culprit in this case. But it might also be this one, because there seems to be also some squeezage right there at the top. We will need to confirm that with our thermal camera. Oh, this looks like this got liquid damaged. Very interesting. Because I can also see a solder ball right there under that resistor. Right there's also a solder ball. Very, very interesting. Okay, let's see. Did any more of this area get anything? But this looks clean. The rest of it looks very clean, but this area definitely has gotten some liquid on it. And here it seems that this MOSFET has died. I gotta say, it's really good to see in this microscope. Like, wow. One of the big things is that this has some anti-glare feature with the light, because the light I was using before, I always had problems with reading the numbers and letters on parts, but you can see it's very clear with this one. It's very, very nice. So we will need to go over to voltage induction to see exactly which MOSFETs are faulty, because there might be multiple ones here. So let me get the thermal camera out, and what we will do, we will solder, or we will be putting 1 volt into the 12 volts right here, and we will be connecting the ground to here. So our ground is now connected to the input of one of these inductors, and The other side, we will be taking tweezers and going to go into the 12 volts. And let me get the thermal camera out. And we will see which MOSFET is our culprit in this case. So, and this is pretty obvious which MOSFETs it's going to be. It's going to be the third pair. These two. The second pair from the top. It's really not too easy for you to see. But it's these MOSFETs right here. So let's get to removing those MOSFETs. If we attach power, we might even have to remove a little bit. We might have to remove the complete phase there, because I think it might be completely damaged. So let's do that. So under the microscope now, this is exactly the phase that we've seen before under the microscope, where we saw solder balls squeezed out, and we thought that this will probably be the damaged phase, and it is. And what we will do now is we will be removing the complete phase, which means I will be removing all three of these MOSFETs, and we're going to completely rebuild this phase. Because we will be applying a lot of heat, I will be removing these three capacitors here, just to be very sure that these don't blow up in my face. So the capacitors are now removed, as you can see right there. And I've zoomed a little bit further out. And let's see now how well we can replace or get all of these three off. Hopefully none of these are welded on. And all of these will we will just be able to take them off just by hot airing them. And now the phase is completely removed. And let's get into measuring our 12 volts. Let's see now. Let's get our multimeter. Let's see if we still have a short. And we still do. There's still something shorted. So it might be that upper phase that we had before, where we were able to see water damage. So let's do the voltage injection again. So let's try this once more. We got ground connected again, and let's connect this. And it's still too hot from hot airing, so I will be needing to take a break from this, and we will get back to this as soon as this is cooled down a little bit. But in the meantime, let's go into the three MOSFETs that we have and see if any of them were actually shorted. I'm pretty sure that some will, but let's go under the microscope and check with our multimeter. So now under the microscope, we are in ohms mode with our multimeter, and let's test these MOSFETs. So source to drain seems to be fine, and to gate, this one seems to be fine. Okay, let's move further to this one, and this also seems to be fine. Okay, let's go on to this one. And I currently cannot find any short circuit on these ones between source and drain or even the gates. Very interesting. But these were getting hot, pretty sure. Let's go on to voltage injection again and see for the other ones. Let's get these to the side and have in mind that I couldn't actually find any shorts on them. So let's now see, the area is a little bit further cooled down. So I would think it's that one. One of these upper two ones. Because these at the top seem fine. These at the bottom are also heating up. But I think it will be that one at the very top then. So let's remove that as well. I've now removed those upper two ones as well. And let's now see under the microscope with our multimeter if those are shorted or not. So let's now see. Let's go onto here and there. And still nothing on this one now here. Still, none of these are shorted. Like, I do know we do have a high side MOSFET shorted, but we should also have a low side MOSFET shorted because we have a low resistance from 12 volts to ground. So it's really weird because if you look, my props are working, but yeah. So to get you up to speed, I desoldered the whole face of the left side of the MOSFET except these two and these two, and we still shorted. If I can show you that going into there, we still have a short circuit. So I'm just going to directly go over and remove these two because these are the ones that got damaged, like physically, what got water damaged, and I should have probably started with those or with maybe even that one. But the heat signature really did point into this direction. But let's do remove these ones and then see if our short circuit is resolved or not. And now finally I've found a shorted MOSFET, if you can see right there. This one is shorted. And let's see for this one. And the high side and the low side MOSFET was shorted on this phase. That's why we got such a weird signature of heat. Oh, this is so rare that this happens, that the high side and the low side fail together. Oh, let's now see. I'm now probing the 12 volts of the CPU. And let's see for the resistance. And I get open line. If you see, I had to go into the mega ohms to get a reading here. Kilo ohms right there. Kilo ohms and rising onto the 12 volts. We are here probing the 12 volts and this is the resistance. So yeah, I've removed way too much of the phases for no reason. Well, because the heat signature was pretty hard to interpret because everything was heating up. So I will be soldering all of these back and probably will leave out these two. Will clean up the area and we will see how this board will react then. So let's see. The passive power consumption, 140 milliamps, looks very nice. And let's hit the power switch. And we got about 3 amps. This looks very good. Let's get a keyboard just to know if this is booting or not, because I don't have any video output on here. Let's see, 2.8, 3 amps, 2.1. This looks very good. This looks like a booting sequence. And let's see, I have the keyboard here to see if we get any activity. But the amperage is still jumping, which is very good, which is what we want. And there it is. We have indication. So this is booting. Let's turn this off quickly. Let's get video output into here to get a BIOS screen. And let's see if we can quickly get a BIOS screen. And if we have a BIOS screen, then we will have, yeah, there it is. We also already have a BIOS screen. This worked fine. Nice. Let's turn this off now. And this means this board is fixed, basically. What we now need to do is we need to place 2 more MOSFETs onto there, clean up all of this mess that I made, and then this board will be pretty much fixed. So let's do that next. So after now having confirmed our problem, and that these 2 MOSFETs were faulty, let's now get 2 new MOSFETs onto here. So we need a high side and a low side MOSFET here. We had the 4C10 and the 4C06, I think. And I have both of these here. I have new ones of these. So we have one here and the other type here. Let's get under the microscope, put them at the place where they need to be. So we now have both of our MOSFETs, and I will be soldering them on. And the big question will be if this controller has survived and if any of these resistors might have been damaged in the process of being liquid damage as well. And before I will solder them, I will also clean up the solder here. I will take all of the solder off of here and replace it with leaded solder before I do that, just to be sure that this area will stay clean after that. And I'll probably also have to reflow, yeah, we'll also reflow these ones just to be sure with some flux. So the MOSFETs are now soldered on, the area is cleaned up mostly, and let's now try to build this up and see again if this phase now blows up because of the MOSFET driver or not. So let's now see. We get positive power, and let's turn it on and see if anything reacts. Okay, our phase didn't seem to blow up. That's very good. They don't seem to get too hot. Let's see, the board is probably power cycling. And let's see if we can get a boot screen now. And there's our boot screen. Okay, very, very good. So it still boots. What I now want to do, I want to use my oscilloscope and I want to probe every single phase because I have unsoldered and soldered all of these phases, and I've replaced this phase, and I now want to make sure that every single of these phases is running correctly. So what I will do, I will place an actual cooler onto here, and then we will flip the board up, we will turn it on, and then I want to probe every single inductor, and we're going to see on the oscilloscope how our waveforms look like. So this is the setup now. I will now turn the board on. And the bot will be running, and what I will do now is we will flip this camera that you're looking right now onto our oscilloscope, and I will be taking the board like this, and I will be probing the backside of the inductors. I will be keeping this onto here, or I will even go as far that we have a BIOS screen that you can definitely see that the board is still on and that we're probing the board. So the board is now running and we are in BIOS. We can see the power consumption, very static. Let's now see the oscilloscope. So we now can see multiple pulses, and now what I will do is go closer to each single pulse. My trigger doesn't seem to be very happy with the falling flank, but that should be okay. Let's go. So this is the very lowest phase. This looks fine. Then the next one, this also looks okay. The next one looks okay. Second to last one. And the last one that was under the heatsink. And this phase seems not to be running. This is interesting. Okay, so we might want to have a look at that phase. And also cannot get anything on this upper phase. Nothing on that phase also. So the two upper phases, or even three upper phases, I cannot get, but that might be SOC, and I'm not too sure how it is supposed to be looking. Oh, okay, forget it. I was just probing. I think I was just probing the wrong side of the okay, no. For the very top one, we just get a DC reading. As you can see, no matter what side we probe, we just get a DC reading. This is a working one, and this one doesn't seem to be working right. And let's see, this one does have a right one. This is the repaired phase that we had. So it looks a little bit different, but it looks to be fine. And this is the one next to it. So we have a single phase that seems to be not working properly. I will have a look in the board view if this is something special, something different, or if I just made a mistake with the soldering. So right now the board isn't running, and I've measured the passive components around here, like all of these resistors that are connected to the gates, and all of those seemed fine for resistance wise. And then I was probing the gates, which is this last pin on that one and that one, and I wasn't getting any activity on the gates. So my suspicion is that that driver, MOSFET driver, is actually dead, and we will have to replace it. And it's really not an easy task, because the 12 pin for the CPU is very close to here. So I will be heating it from the bottom mostly, and then just for the end we'll be lifting it off from the top, and we'll be hot airing from the top to lift it off. And I will probably before that add leaded solder to it, but it probably won't make a difference because there's a big pad, I think, beneath it. But what we also want to do is to take it off of a donor board, which is from this board, as you can see, the 5AZ. This is the component that we need, the MOSFET driver, and we will be taking off of here and be transplanting this one onto the other board. So I've now changed off the controller. It wasn't too easy, but I think it went quite well. As you can see, the connector is still intact. What I did is heat it from the bottom, mostly had leaded solder on there before, and then it was quite easy to place it in to where it needed to be. And let's now see if that had made any change. What I've done already is I've checked all of these pins if they're shorted to ground, because there's a big ground plane in the middle, so that my soldering is correct. And let's now build the board up again and see if that has revived our phase. So after now having replaced that controller, let's see now. And there's still just an DC offset on here. So this phase still doesn't seem to work. The only other thing that I could do now is change out the MOSFETs. But I don't really think that that would make any difference. What I want also to try is I want to solder those capacitors back on that were missing before. So I want to show you the board view right now. So it's this phase right now with this inductor that we just get the offset off. And the connected components that we have is this resistor. That is a feedback resistor that goes onto here. I think it's not a feedback, it's a pull down resistor with a capacitor connected to ground. There's nothing else connected to it. So the next connections that we have, let's go from the controller. So you have the upper gate, you have this capacitor, and then you have this 10k ohm resistor that also goes to ground, so nothing more. It's not shorted to ground, and this resistor is also fine with still 10k. And then let's go to the next one. The next one is this an upper gate? This goes onto here, onto a capacitor. Okay, I cannot really tell you what this 2.2 ohm is from here. Let's go for, this is a PWM signal. This is coming directly from the controller, so nothing to check there. This is ground. Then pin 5 goes to the gate. There's nothing in between there. There's just VCC on here. So VCC is supposed to be coming from VIN12 here, between this 1 ohm resistor. So 12 volts is the incoming for this controller. We can check the 12 volts, but I'm pretty sure it's present. And number 8 is the actual feedback phase coming in between those MOSFETs. So there's really isn't much that is between those. One thing I can imagine is that this controller might be partially damaged. I don't think it will be. I have replaced this controller now with a known good one, and what there would be left to do is to maybe replace one of these two or both of these MOSFETs, but I really don't think that there's going to be any big change in that. There might be that this phase is actually just disabled. It needs to be enabled by the controller, but I'm really not too sure, to be honest. One more thing I will do is to check this this here, if there's the supply voltage on here. But if that is not present, I will just go over to doing stress tests, and if it doesn't crash, I will just keep it at that, because I do not have anything else to check here or to change here. So I was just checking if you can see. If I go onto that side of that resistor, right there we have 12 volts. And if I go on the output, we actually have 1 volt on here, but it didn't look right to me. Like, I would have expected a waveform like we had on the other ones, but just checking with the multimeter, 1 volt seems it might be fine. This is VCore 1.3, and let's check up here. This is also 1 volts. So I'm really not too sure what to think of this. I still think that this phase isn't running correctly, but I really can't tell you why this isn't running correctly. Because the MOSFETs, pretty sure that these MOSFETs are good. I've replaced the PWM controller and I've checked all of these passive components around there. I sadly do not know what could be the issue here. So we will continue on from here. And what I will do is to solder back these capacitors, clean the board up a little more, and I will get the heat sinks onto here. And then we will do some actual stress tests with the board to see if VCore will withstand the draw. So I've now got the board built up, and let's try to get into Windows. I've put the capacitors back onto here, these 3 ones. I've put the heatsink on the VRM, and I've got a M.2 connected to here. I've got a GPU onto here. Let's go into Windows. I have 4 sticks of RAM. I have a 4100 in here, and we will be trying to run some stress tests and see how this board will behave if I find any problems regarding the SoC line, where I was really not sure if that is an actual problem or not. We're going to find out by these stress tests. So we are up and running in Windows, and we have Ethernet connected. We have some USB devices. VGA is running. We have all 4 sticks of RAM. And let's now run linpack and see if this will work or not. I will be doing a little bit more passes just to be sure that it will properly be stress tests, and then I will get you back into here as soon as that is done. And with that, linpack has passed without any problems. And now what I want to do is to do a 3D application show. So we will be running Unigine Heaven benchmark. And I will get you back into here as soon as that is done as well. And as expected, Unigine Heaven has also passed without any problems. So what can I say? I gotta say, I was proper confused by the MOSFETs, by the situation that we have. I'm glad that the board is pretty sure fixed now. I can't really tell why that one SoC line was still not running. Like, when we saw just 1 volt at the output and not a proper waveform when we probed the input of the inductor. But it seems to be running fine. And what I can also say, I was really confused by the way that the MOSFETs were heating up the heat signature that we have when we were supplying 1 volt to the phase. That was really weird. Like you saw, it was maybe a little bit hard to see through the camera looking at my phone, but a lot of these MOSFETs were heating up, and they were heating up pretty high, like to 70-80 degrees. And I was pretty sure that when we were using the microscope and we saw that MOSFET, that those were damaged because they actually had pushed out solder to the side. And like 99% of the time when I had pushed out solder on the sides, the MOSFET were actually bad and were damaged when that has happened. But in this case, it wasn't actually that. The other ones that were obviously damaged, which had the water damage on them, were actually the faulty ones. And this is the very first time that I had a high side and a low side MOSFET shorted, both at the same time. Probably that has something to do with the way that the heat signature went when I was injecting the voltage there. But I gotta be honest, I didn't expect that to be the result of a shorted high side and low side MOSFET, that the other MOSFETs will also heat up in that way. But you saw how I had to go on with desoldering all of these MOSFETs just to isolate the problem down to those 2 MOSFETs. And what can you do? It took some time, but with my usual method of voltage injection, I was just not getting anywhere. So yeah, I hope you still learned something. I hope you enjoyed the video. Thank you very much once more, ELIKLIV, for the microscope. I will have a link in the description to their store and to this exact microscope, and there will be a promo code also for that. I am sponsored by them. I got provided this for free just to be sure, but I was not told any talking points. I was just told to do a review and an unboxing, and this is what I did. So I like this microscope. For a beginner, it might be a little bit expensive, but they also do have other microscopes in the lineup, as far as I know. But for me, this is great. This is a big upgrade for me. I can really recommend the microscopes. I don't have much experience with many other microscopes, but what I was able to test here, I am pleased with that, with all the functions that it has. And yeah, so thank you very much. This was Mainboard Medic. Hope you learned something and see you again. Bye.